everyone. We're going to start again with our next video, which is working with data frames, lists, and the disks. So we're going to start out by looking at saving items, and then we will talk about some useful data structures, in particular data frames and lists. So let's dig right in. Okay, so we want to talk a little bit about loading and saving data. So the first thing we want to know is there's kind of some basic things we can do. We have our data files, and what our data files for the most part save is the workspace. So if I come over here to our Studio Cloud, if I come over and I look at this environment tab, which is right here, right now my environment is empty, but if I do something like, let me go ahead and just run everything ahead of this. Boom. Now we've put a bunch of stuff in our class notes. So I'm right here. I'm in class notes for applied business and analytics for business and economics. And I see, what do I got here? Well, I've got a whole bunch of values and even a new function in there. Okay, that's my environment. I can save that environment in an R data file. I can also save particular variables in this as an R data file. And we'll talk a little bit about how to do each one of those in just a second. So let me get rid of that gobbledygook, and let's talk about saving and loading stuff. Okay, so I'm going to put in here, let me get rid of this so I have a little more space, and let's get ourselves an R data chunk. Bing, so there's our nice little chunk. And let's come right back over here, and we're going to look here, and we can say, so our data files do that. CSV files, so comma separated values files, are basically like a text version of a Excel spreadsheet, right? So one page out of an Excel spreadsheet. This is probably one of the most common and generic ways of storing and sharing data. Most every system in the world can read a CSV file. The only thing you want to be careful is it's .csv, and that is the file. The pharmacy is CVS, right? CVS pharmacies. And yep, I have spent hours looking for that bug. So make sure you do .csv, comma, separated values. And then finally, there are things like script files. Those are .r. And we have our markdown files. So if I come over here, I'll make this a little bit bigger. I'm going to come to files. This is our project. And in this file, I have a few things on here. One of the files I have here is an RMD, so R markdown. And that's what our notes are in. Okay, so that's another way of saving things. And that one, we'll just click the save button. So let's keep going. So let's load some file. Let's load a workspace. So what I'm going to do is I'm going to come over here. I'm going to make this bigger. And I'm going to click on this little broom. This little broom right here is going to clear out my workspace. So here's my global environment with all the variables and things in there. I click that broom. All right, everything is gone. Okay, well, let's put some stuff back in there. So what we want to do is I want to do this load, and I want to load this book sales data project. And this is the whole workspace from book sales. So we've been playing with that stuff throughout the whole chapter here. And now we're just going to load all of it up to this date. Now, here's the first problem. You don't have this on your computer, but I'm going to click on here. I have this available for you. All the data that we used in the book is available at that URL. So we just have to go get that. So let's do that. But we're going to make R do it. So the first thing we're going to do is we're going to load. We're going to use the load function. And what the load does is it loads our data files. Okay, bing. And now what I'm going to do, I'm going to hit return. And notice how it formatted that for me. It put my parenthesis here, and tab that in. That just makes it a little easier to read. And then I'm going to type in URL. All right, URL just tells it I'm going to give it a web address. Okay, and nope, I absolutely cannot remember what that web address is. It's tiny.cc/ABE-data. All right, so I'm just going to copy it from right here because I'm lazy. Okay. And it says it's right there. And now what I'm going to do is I'm going to do another slash, okay, /, just like that. And I want to tell it what file I want. And it's going to be book sales R data. All right, so I'm also lazy. I'm just going to copy that right there. All right, bring that right over. Put it right in here. Paste. Boom. And so what is this going to do? URL is going to return something to load that will make it easy for load to load this. All right. You couldn't just give the load function this web address. It can't quite handle that. But URL makes it so it can. And so we have a nice little nested function. Let's run this and boom, look at all this crap we have in here now. All right, so a whole bunch of stuff that's basically kind of the accumulated crap that was developed through the previous parts of this chapter. All right, but that's saving a whole workspace. So we brought in the whole workspace. Okay, next, let's say we want to bring in not just this. There's other stuff you can do in here, set the working directory and all that. You really don't need to worry about that in RStudio. RStudio's got that figured out, so I'm going to have you skip that part for right now. Or at least RStudio Cloud has this stuff figured out for you. So right down here, don't worry about it. Let's go on and, well, we're loading workspace files. So I want to load just one file. Yeah. I've got all that. Now I want to load some data. So we have some data in the same place, all right, but it's in a CSV file. So let's do that. And to do that, we're going to need the function read.csv. Okay? There's other forms of this that are a little better probably, but for right now, we're just going to stick with this one. Now, what read.csv does is it takes and reads that CSV file and returns a data frame. So we'll have to talk about a data frame in just a minute, but we'll do that in just a second. Okay? So let's do that in a minute. But for right now, let's just get one loaded. So let's see, what did they want us to call it? Books. Let's just copy this. All right, we're going to copy this data right here. Paste. Great. But it's not going to find booksales.csv. If I just run this, what's going to happen? Oh, it cannot open a connection. It can't find that. So what we're going to have to do is we're going to give it the same function here. All right. Paste URL, but instead of having it say book sales are data, okay, it's going to say, let's get rid of that, booksales.csv to get at that CSV file. All right, run this. Bing. And if I scroll right here, you'll see right here under data, it says books. It's got this little thing on here. I'm going to click on that. And that opens that up. And if I click over here on this little, I don't know, spreadsheety looking thingy, it brings it up in the viewer. All right, so Bing, I have a tab over here that has this data frame on there. And there's some filtering you can do. There's a little bit of stuff. You can't directly edit it here, but you can see what it looks like. Okay, there we are. So we've loaded our first data frame. Isn't this awesome? All right, let's keep going. What about, okay, and there's other things we can do with import. We'll talk about that later. How about saving? Well, we use the save and the save image. Save image saves the entire workspace. Save just saves individual things. I don't ever use save image. What I use is save. And what's really handy about that is I can say save some data. I'll tell it what file to save it to, so I can save it to an R data file. Okay, so it's an R data format, and that'll be a little faster for R to load later. And call it good. The other thing I can do is I can put data into a list. So say I had two variables. Say I had, and I don't know why they have these in quotation marks. They don't need them in quotation marks if they're variables. If it's actually text, you would have to do it that way. But say I had two data frames, I could put those in a list and then save the whole list. And what's really nice is when I come along and reload that, It loads it up with all the same names and everything, just as we did. Okay, I'm going to leave this as an exercise for you to do this on your own. And we're going to move on to the next topic, which, okay, let's talk a few useful things about variables. So there are a few special values. These values are, all right, I'm going to highlight these. All right, let's come in here. These values are infinity, INF, all right, NaN, which is not a number. So if I take 1 divided by 0, I get infinity. If I take 0 divided by 0, I get not a number, right? So there's actually quite a bit of technical stuff behind these two numbers and why one is the other and one isn't. And it goes back to a study of something called numerical analysis, which is basically how to do math with computers. But we are not going to get into that. All right. So basically, there isn't a mathematically defined number for this, as opposed to infinity. So here, 1 over 0, it's saying we'll take the limit as 1 over x as x goes to 0. It becomes infinity. How many groups of 0 can you make out of anything? Well, an infinite number of them. All right. So if it gets infinitely large, it's INF. If it's infinitely small, it's negative INF. All right. So that would be negative infinity. And then not a number is different, so it just doesn't exist. Okay, the next one is NA. NA is missing. All right, so if I have data and one of those data values isn't there, I just don't have it, it's missing, it would be represented by NA. And then null is kind of a special value. It just means nothing. All right, so I could have a list that's null. Right? There's nothing in it. I want the list to be there. I want R to say, okay, this list, here it is, it's named, there's nothing in it yet. And it's null. Okay? Those are those special values. Variable classes. Oh, so this is something I don't get exactly correct. I actually get a little bit wrong because I'm old. And I think of things called variable types. So in a computer programming language, I want to say what each variable's type is. So X, think of that as a variable, that's a box. And I want to tell the computer, well, what kind of stuff can go in the box? Well, there's the basic primitive variable types that are kind of the underlying programming language that creates R. But once you get into R, you go a next level up, we have these variable classes. And if you've ever done any work with C++, that also gets a little confusing in the nomenclature, but don't worry about it. Basically, what we're going to say is what is essentially like a variable type. It's just a little higher level. And so we can, X is numeric. X could be a character if it's a string. All right. It could be a binary. And so you can use these functions to figure out what a particular variable would be. So class is a high-level classification. It captures some meaningful distinction. So for instance, that is a string, right? It's a string because it has quotation marks around it. But it's also a date. And so we can create this and make this so that R recognizes it as a date. Okay, that's one example. So you can get that from the class function. The mode of a variable refers to the format of the information that the variable stores. So for example, our stored text data or numeric data, for instance, which kind is useful? Sometimes, if you think of this date, sometimes having it stored as a number that we can do something with, some mathematics on, is useful. Sometimes having it stored as a string such that we can read it, so a character, a valued variable. Okay. The final thing, type, is a very, very low-level thing. That's kind of the underlying programming stuff. And so you could have things like different numbers. You can have an integer, or you could have a double precision or a double floating point variable. These are much deeper, and we really are not getting into that in this class. To be honest, we probably won't get past level number 1 here and thinking about it in terms of its class. Okay, so let's talk about a particular type of um, data type or data class in R, and that's called a factor. These are really, really useful. And what a factor does is it works with groups. So sometimes we have numeric data, sometimes we have categorical data. So for example, let's take we could have numeric data like if let's do a sports analogy. So we're um, River Falls is very close to the Twin Cities, and so there's a little bit of rivalry between Wisconsin, so the Green Bay Packers versus we're closer to the Minnesota Vikings. All right, so you could either be a Vikings fan or a Packers fan. Now, I realize if you are one of those, then one is clearly superior. The last time I watched football, John Elway won the World Series, and yes, that was a joke. Probably not a very funny one, but it was a joke. In any event, you have groupings, categories. I can't say one Green Bay Packer fan is, worth two Viking fans. It just doesn't work that way, right? They're two different categories. I could, on the other hand, say there are, 500 Viking fans in the city of River Falls versus 1,000 Packer fans in the city of River Falls. I'm making numbers up. I have no idea. That could be numeric data, right? So I could think of this in either way. I can think of two different variables to describe similar kind of information, one that's numeric and one that's categorical. Well, factors is how we tell R that the data we're looking at is categorical. All right, so in this case, we've got a group. All right, it's going to be 1, 1, 1, 2, 2, 2, 3, 3, 3. So we have three groups. Okay, now we could do something like group plus 2. All right, and that adds 2 to each group, and then group 1 becomes group 3, and so on and so forth. Well, the problem is it doesn't matter, right? So maybe what we want to do is we want to tell R, hey, look, groups are a factor, right? So group is telling me which group something is a part of. So Packers fans is 1, Vikings fans are 2, and people like me who just don't know the difference is 3, right? All right, so I'm going to copy that one. Let's go here into RStudio, and let's talk about factors. And let's get ourselves a nice nifty little R chunk. And let's paste this in. Paste that in just like that. And I'm going to clear all this stuff out so we can see it a little better. Let's run this. Boom. Now we have our group. That's our grouping variable. But that grouping variable, they're not numbers. They're just categories. We just happen to represent them as numbers. So let's do group. And then we're going to store back in group, so kind of overwrite it, as dot factor. Now there are several different functions that are as dot. And basically what that tries to do is it's going to coerce a variable from one class into another. All right, so in this case, group is a numeric variable or a numeric vector, and we want to turn it into a factor vector. All right, run that. Bing. And now group is a factor with 3 levels. And if we type in group, what do we get? All right, boom, it gives us the vector, and it says we have levels 1, 2, and 3. Easy peasy. Now what does that mean? That means we have the levels, each group within the grouping is 1 level. Okay. Cool, so let's keep going. So if you do class as group, you're going to get a factor. And what happens if we do this group plus 2? Well, what's going to happen? Warning. We're trying to do an operation on a factor that isn't numeric, and then we get all NAs. All right? Because addition isn't meaningful in factors, right? I mean, it doesn't make sense. It's not numeric data, it's categorical data. All right, so we could label these factors. All right, so let's see. Our is not infinite. Okay, well, let's try this. Let's create one called gender. And let's see here. I don't know how they did that. So let's just go ahead. We're going to make it ourselves. And let me show you. We'll do a little trick here. All right, and this actually should be not gender, but sex. All right, because it's biological. See? There we go, and we have a problem because we need some commas. Comma, 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 comma. All right, so my English teacher is not going to be happy with me because I put that space there. It shouldn't be. It should be the other way. R doesn't care. All right, now we're going to do one more thing. We're going to do this as dot factor. We're going to put it all in one thing, just like that. Easy peasy. And then we're going to copy this down. There we go. And we see for our new variable sex, we have 2 levels, 1 and 2, just like that, in easy peasy. So let's come back here and let's say we could do group equal gender, and it's going to say, oh, that doesn't work. They have different sets of factors, blah, blah, blah. Let's do this. We're going to use the function levels. Okay, so let's do this. Copy, copy. Levels for group, we have group 1, group 2, group 3. And let's do the same thing for gender or for sex. All right, we'll do sex and we'll do male and female. All right, or you could do female, male, it doesn't matter. You just have to make sure that the first one here, so the 1 group needs to be your group 1. And so if you've coded your data so that 1 is equivalent to male, you better put male first. If you've coded your group so that, or coded your data so that female is 1, well, you better put female first, right? It just needs to stay the same. And boom, what do we got? All right, levels, group 1, group 1. Oh, I did this wrong. Wait a minute. Oh, that's the problem. There we go. Copy. And notice we put print. We didn't actually have to do that. We could get rid of the print and just do it like this. It's the same thing. There we go. Male, 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 female, female, female. And what it's done is it's changed the way this prints out and the way it's used. This is really useful when I'm doing plotting because I may want to do a box plot that compares, I don't know, average driving speed over the speed limit of males versus females. All right, and I want to do a box plot of those two, see what happens. Or a box plot looking at these 3 different groups, the difference between there. And I know we haven't talked about box plots, but you should have talked about those in Stats 1. Okay, bing, those are factors, really useful. And so it says, moving on. Great. Final thing we really want to talk about is data frames. So data frames are the kind of the basic fundamental unit of data in R. And so the way you want to think about a data frame is essentially one page or one sheet out of an Excel workbook. And we can have as many of those as you want to in a particular R session. All right, you can have hundreds of them if you want. And what's going to happen is in that data frame, you have a big box of data. Each row of that data is an observation. Each column is going to be a variable or a series that you're looking at. So you could have data on workers or on people, and they could have an age in there, a gender, maybe what group they're a part of, and then a score they got on some evaluation. Okay, and that gives you the data, and you have in that bit you can have what's called a cross section. Now data comes in various forms. You have a cross section you can have that has many individuals observed over at one point in time. You could have a time series where you have one individual being observed over time, or you could have a panel where you have several individuals being observed over time. All right, those are the kind of three basic structured data forms that you can use in terms of our analysis. We'll stick primarily with cross-sectional for this class. To get into, say, time series analysis and panel, you'll want to take econometrics, which is Econ 426. Okay, so we've got our data.frame function, which is what creates a data frame. So let's create a data frame. And one of the things I think I need to go back and do, well, right here, we have our age and our score. So we're just going to work with that. We have age, we have score, and we have sex, not gender, because we're using that because we only have two here, right? And so let's go ahead and we'll talk about here, data frames, and there we'll hit our little R thing, and we're going to paste in this, paste, there we go, age and score, and from that we're going to make our data frame. So let's go ahead. Let me show you how I'm going to show you two different ways to do this, and we're going to call this data frame, I guess this. All right, so let's paste this in. All right, so data.frame, and I just gave it the variables. And let's run it. All right, gender not found. Oh, because we changed that. There we go. Bing. And there's our data frame. It tells us that sex is a factor, that group is a factor, score is a double, or it's a numeric. And age, it's also telling us is a double. That's a double precision variable, so that's the low-level data type, but basically it's a numeric value. Okay, that's one way to do this. I want to show you another way that's a little more explicit. So let's do ex pt, and we can call it 1. And I'm going to do data dot frame. Okay, now I'm going to hit the return button and bring it down. And I want to talk about age. Age equals, and I'm going to put this in here. Now, one of the things I like to do, rather than do it this way, I want to take age, just like that, and I want to surround it in backticks. I find that's just a little more useful. And then we can do the same thing with score. I can just copy this, actually. All right, and again, I like to put the score in backticks. One of the things it lets me do is when I do that, I can use variables that have spaces. Score on test. Okay. And I'm just going to run that one. I'm not, we'll use this one for the main thing, but this is just a demonstration. And we'll copy this. Now, this is either going to work and I'm going to look really cool, or I'm going to need to change those to single quotes. And I got to change them to single quotes. Object expt1 not found. Oh, what did I do wrong? Oh, there we go. I forgot to put the little dash. There we are. Bing, there we are. And we look at expt1, score on test. And this didn't work very well. So what I want to do is everywhere but here, I can use the backticks, and that lets me use. It works better. This is a little bit of a new part to ours stuff. But for here, and I can just highlight this and then hit the quotation mark and it puts it in there. Here I need it to be in quotes. There we go. Well, that still didn't work right. What am I doing wrong? Oh, look at what I did wrong. This is what I did wrong. That needs to be an equal sign. All right, so okay, so one of the things we can do when we work with this stuff is you can define the variables right within the function data frame. Now here what I'm going to do is I'm going to put the actual value that I want to call it, so here age, but I'm going to surround it in these backticks. And what doing that does is it lets me, if I want to, I can use a variable name that has spaces in it. Now, why would I want to do that? Well, it's really useful when I go to plotting the data. Now, when I come down here, though, I end up with score.on.test. It replaced all the white spaces that I so neatly put in there with dots. Well, there's a way around that too. I'm just going to come right up here to data frame because I don't remember what it is. I'm going to hit tab and I'm going to say, all right, check names. We're going to set that equal to false. And if I do that and I rerun it, I've got spaces in my variable name. But if I do that, if I do use spaces in my variable name, then from then on, I have to surround that variable name with backticks to use it for any purpose whatsoever. Okay? And with that, we can talk about accessing some of the information on these data frames. So let's do that really quick. Let's say, and I'm going to get rid of this part because we don't need that anymore. We're just going to worry about expt for right now. So expt, let's say I just want one variable out of there. I'm going to type a $sign. Oh, and looky there, it spits up a list that lets me get what I want. All right, so all I want is the score. And if I then go up here and run this, all right, the very last thing in my console, and notice for here in my notebook output, I have this guy prints, then this guy prints, then this guy prints. Well, notice I can click on, well, there's the first data frame that printed. There's the second data frame that printed. And then here's the rest of my console output. All right, so it lets you split up that output a little bit more. And boom, those are the output on their scores. Okay, and what I can do for anything inside of a data frame, I just put a $sign and then I can get at it. How would I do this expt1 $sign? How do I get score on test? Well, if I just scroll down there, notice it just puts it in backticks and poof, I can use it just like that. So there you go. And it'll still run. All right. Very good. This is getting really, really long, but we have one more thing we need to cover in this particular part, and that's lists. So lists are really handy because what they let you do is they let you combine a whole bunch of stuff together. So let's go back. What about the combine function? What if I just did this? Let's do Dan right here. This is Dan's list. Okay, so it's a list of information about Dan. He's 34 years old. He is definitely a nerd, and his parents are Joe and Liz. Easy peasy, right? So we can do copy. Let's come back here. Let's make ourselves a new thing called lists. And let's get ourselves a new R chunk. And let's just paste that sucker right in there. Great. I can run that. Let's do Dan. We'll print Dan out and Bajinga. Easy peasy, right? Notice there's a little dollar sign here because I can access any part of that list the same way I would a data frame. I just put that dollar sign and then I can get at the things inside of it. All right. But what would happen if instead of using list, I do all the same thing, but instead of list, I use the combine function. Let's find out. Okay. And then I'm going to show you a quick trick. I'm going to highlight this whole thing. I don't want to run it right now. So I'm going to go up to code and I'm going to do comment, uncomment lines. Bajinga, now it's all commented. All right. And it won't run, right? Because we talked about comments. Let's run this. All right. All right. Well, it ran. What did it do? Let's see here. Let's clear this. Yes. And let's run this. Okay. So Dan is now a character. All right, so what did it do? It took all of these and made them into characters. Why? Because that was the best it could come up with, because there were characters in there. So let's go ahead and let's print out Dan again and run this. And there, we don't get a list, we get a vector where age is 34, nerd is not true, but a string that says true. Parent 1 is Joe and parent 2 is Liz. It's just not the same thing at all. All right, here's what combine does. Combine gives you a vector or a list. Well, not a list, a vector, where everything has to be the same type. So all of these different entries, it converted them into the same type. But if I get rid of this and I go back to my original, all right, I just used a shortcut key there. I go back to my original and I rerun this. Now Dan is a list of 3, and you can see there's 3 different things, and each one of them, this is a number, 34. This is a logical variable, it's true, and then we have a character vector, all right, with 2 elements in it, and we can see that right here. And so that's what list does. List lets you combine lots of different types of variables together into one form. And what's really cool is you can combine it all into one list and then you can save it, right? Okay, so there we go. We have lists, we have data frames, we can load things, we can save things. We are really cooking with gas, right? Talk to you in the next one.